Hey, what's up guys? My name is Cherno and today my code is being reviewed. Not by me, obviously. Today, joining us, we have Nathan Baggs.
Hey, yes. I'm Nathan Baggs. Thanks for having me. Big fan of the channel. So I've been doing YouTube for about 3 years now. I focus mainly on sort of low-level reverse engineering of games, but professionally I've been a C++ dev for about a decade. So I'm kind of very interested in that, and I love doing code reviews, and I thought it'd be great for us to kind of get together and talk C++ for a bit.
Let's get right into the roasting.
So yeah, I had a look through Hazel, so thank you very much for kind of giving me access to it, and I spent a few...
I was going to ask you actually, what branch is this?
I think it's whichever one you recommended. Is it develop?
Dev, I think.
Dev, sorry,
Yes.
yeah.
Okay, yeah.
It was whichever one you recommended, but
Yeah,
I have not
Dev is good.
pulled any changes since I started looking at it because I wanted all my notes to make
Okay.
sense. So obviously if some stuff may have moved on.
So it's like a couple weeks old?
The last commit I had was this one. So that was
So
12th of August. Okay,
Cool.
fine. Again, I wanted kind of like a fixed point in time to be looking at.
Yes, of course.
I followed all your instructions, as you said, so I built it for Windows. I used Visual Studio 2022, and that was absolutely brilliant. Like, it all pretty much worked. I think I had some issue with the Python, but I think it's just due to the weird way that I've installed Python through UV rather than just as just on the path. So,
Yep.
but and I managed to run Hazelnut and had a play around, and it was pretty cool.
Take note, everyone who sends code in for code reviews, by the way, that if this engine can run easily, then so should your very simple code.
Yes. Built out and just from dev, just built, which was good. I've opened up Enum just because it's easier for me to kind of navigate around, but I haven't edited anything or anything through this. I just took the instructions as were given to me. So yeah, I just basically started at what I believe to be the beginning, which is entry point. And then I just kind of meandered my way through somewhat organically, like looking at things, drilling in, drilling out, and then I just made a bunch of notes. So I'm going to go through those. Preface this with I've never worked in the games industry. I'm a hobbyist OpenGL dev at best. I've looked at Vulkan once, and I did Hello Triangle, and there was 3 weeks of my life. So I have almost nothing to say on the actual rendering side of it. But yeah, I guess I've worked as a professional software dev, C++ dev for about a decade across different industries, but never graphics. So I probably have a slightly different style maybe to you. So I kind of looked at it through the lens of how maybe I would have approached some of the problems you had. And that's not to say that it's definitely not better, it's just different. So a lot of my notes are actually just questions of just why. I'm kind of curious to know why you did it this way, and what if there's any alternatives you kind of considered. So I guess the first thing that really sticks out to me, it sticks out like a sore thumb, is the raw delete. I spent a large part of my life trying to move away from raw new and delete, and everything is just unique pointer or some sort of RAI primitive. And what I picked up from your code, I think one of the massive differences in our style is you don't use exceptions, whereas I'm very pro exception. So for me, this is not bad, but if run through, then you would delete. Do you know what I mean? But you don't have that problem. So I guess that's maybe part of the reason why you've just sort of newed in create application and deleted afterwards.
So to me, this is such a very sort of clear-cut, specific sequence of events that happen in the very, very core of the application. And it, I guess, helps to define very clearly when, say, the constructor and the memory for application will be allocated and then freed as well. So you can see that we have create application on line 15. That's very clear. And then we have the actual app running on line 17, which is the main loop and everything. And then we want to make sure that we delete sort of the app before we shut down the core. And then it's in a while loop so that you can trigger a reload of the engine or the editor. So, I mean, we could have obviously done a shared pointer or a unique pointer and then freed it, I guess, by calling reset or putting it in some sort of scope that ended before shutdown core. But because it's not really getting shared, I guess, across our application. It's not like we're getting this application pointer and then putting it into some other function and then who knows what will happen there. It's all sort of done in a specific sequence, and it's very clear, when it gets created and when it gets shut down. And to me, it makes more sense to express that clearly with essentially a new and a delete. Does that make sense?
Yeah, I think that totally makes sense. Yeah, no, I totally get it. And I think because this is probably not code, because you're writing an engine, but this is not part of the engine you expect people to probably interface with. This is kind of provided for you. It matters less. I guess just me when I do it, initialize core and shutdown core would have been a constructor and destructor of another class, and I would have it would have just been within the scope. And but I think that's just the way my mind kind of approaches these things. But I was just curious. What the kind of your rationale or your approach was. Yeah,
it's just a way to be a bit more explicit about I guess startup and shutdown. The other thing is we want to, because the application is a little bit more client side, well, it's a lot more client side than the core. We also want to make sure that it's clear that, okay, the application destructor that the client has created, that will definitely run, before we shut down the core, because that might want to use parts of Hazel that obviously would get shut down when you shut down core. So it definitely has to be deleted, before we get to shut down core.
Yeah, I got you.
And then it's okay, well, how do we express that? By calling .reset, what's the point? Or I mean, you know, the scope is fine. Like if on line 15 you had a unique pointer and then you ended the scope on line 18 instead of calling delete, then it would achieve the same thing. But then it's like, you know, what's so bad about calling delete? What that probably should be is hdelete, which is a little macro we use for tracking.
I've seen that elsewhere, yeah.
Yeah, so that's probably a little, this obviously would have predated that macro because this was one of the first things that got written.
Yeah, okay.
But yeah, if we, like, we don't do this kind of, we don't do this kind of thing throughout the code base, obviously. We use quite a lot of, like, it's rare for us to do new delete unless it's like a specific memory operation. Like another place I can think of is like the render command queue, because that's sort of raw memory dealing with that kind of stuff. But yeah, because this is like it's like a single sort of point that is a lifetime of basically the whole app. And so having that explicit sort of creation and destruction, I think, makes things very clear.
Yeah, that's cool. And like I said, I'm not saying that in any way this is like right or wrong. I was just kind of curious what.
Yeah, of course not. No, this is good because
it also, my world, I very rarely write it.
Yeah, this is good because obviously it makes me sort of think about it as well and try and justify it, and then maybe realize that it should be different.
How long ago would you say this code was written, like this line?
Probably like in 2018.
Okay, so quite.
I mean, it probably changed. It probably would have changed like.
Oh, of course,
a little bit, but not much. I wouldn't think so. Like, I know that while loop got added when we introduced Vulkan, because at one point we supported OpenGL and Vulkan, and then I wanted I wanted a way from the editor to be like, okay, now restart the editor, but with the other render API. And so that way we could just go like file, restart in OpenGL, and it would obviously, you know, shut down, and then the while loop would go back up to the start and basically rerun the whole app. So that's when that would have gotten introduced. 2020 for the while loop, I think.
And then you've just sacked off OpenGL and just full Vulkan now.
Yeah. And then probably a year or two after that, it was like, you know, why support OpenGL? And it's just such a different way of programming an engine when you're dealing with the constraints of OpenGL. And it doesn't make sense because for our sort of target platforms, target devices, they don't need OpenGL. It's mostly like, I guess it would be DirectX, Vulkan, and Metal would probably be our primary APIs. And then, OpenGL just doesn't really have a place.
Yeah, because those three are kind of the same sort of like, it's like generation or kind of philosophy of sort of like low overhead graphics APIs.
They're definitely more similar. I think Metal would probably be the highest level out of those if you compare DirectX 12 to Vulkan, because DirectX 12 and Vulkan are quite similar. DirectX 11 is a bit different, but there's definitely, it's easier to adapt those APIs together, I would say, than OpenGL, which is the highest level of all of those and quite different.
Horrific, great big state machine where you just sort of set all the levers and you pull the big switch at the end and hope you don't get a black screen.
Yeah, but it's great. It's great for so many use cases even today. It's just when you're when you're spending this much time developing an engine and you want a lot more control and you want it to be a bit more robust for actual distribution, it makes more sense to use the newer APIs. You're still using OpenGL, right?
Yeah. So I'm writing a little game stream on live at the moment, but like I say this probably every stream because people always ask. Like my whole thing is like I'm not writing an engine, I'm just writing a game. Like I only want to write code that is in service of getting that game towards the end. So it's as soon as I don't need any functionality, I'm not writing it. So I've done a lot of stuff from scratch as like a teaching thing. So I've written like my own maths classes, but they're very incomplete because until I needed to subtract two vectors, I just didn't write that code. It was that kind of thing. Do you know what I mean? I was literally just building it up little bit by little bit.
Because then you're not wasting time developing stuff that you don't really need. And also OpenGL, I think is really, it's the best way to probably do that, because that way you're not focusing, you know, you're not spending 80% of your time developing this game just working on the renderer, not even the renderer, just like the renderer backend.
Well, this is it. Yeah, no,
I would also use
it's just a simple forward renderer.
In this case,
you know, I use DSA, so 4.6 and a few other modern bits, but like, it's good. I really enjoy doing it. It's good fun.
Yeah,
just got SSAO done, which was
nice.
Burnt a few streams trying to get that done.
Yeah, cool. I should review that, I think, next time.
We'll definitely flip this over next time and you can have a look at my horrific OpenGL code. But there are a lot of exceptions, so that'll be something for you to comment on.
That's all right. I'll just like find replace them with a blank space or something, just so I don't have to look at them.
With a return 0.
Yeah, return -1. Like this was very invalid.
Yeah.
You know what else is really good at reviewing your code? Rabbit CLI, the sponsor of this video. Rabbit CLI is a free terminal native AI code review tool that helps you catch bugs, logical errors, and security issues before you commit. And it's really deep, it's really thorough, with each line of code getting senior developer level attention. Look, I get it. You're vibe coding with Cursor, you're super productive, so much code's being written. I won't shame you for that. But is it production quality code? No. And that's exactly where Rabbit CLI comes in. Rabbit CLI is like a senior engineer supervising all of these AI coding agents, making sure they don't hallucinate, making sure that they actually do their job well. It works with all major AI coding agents like Cursor CLI, Claude Code, and Gemini, providing contextual feedback where you need it. And Rabbit is experienced. It's already reviewed over 10 million pull requests across 2 million different repositories, and it's the most installed AI app on GitHub Marketplace. Now they've taken all of that expertise and put it directly into your terminal. Go to coderabbit.com/CLI for more information and get started immediately for free just by running this command in your terminal. It's currently available on macOS, Linux, and Windows through WSL. Thank you, CodeRabbit, for sponsoring this video.
Okay, so the next one I was looking at was I started digging into the application class, and I find this very fascinating design because, again, for me, I really don't like the concept of like two-phase construction and destruction.
Yeah.
The idea that, you have to construct something and then initialize it, and then two-phase destruction as well. I have to call shutdown and then the destructor. I'm kind of curious, like the thought process behind this, because I don't think you don't use this kind of paradigm elsewhere that I saw.
Yeah, I think it's used throughout, and it's just sometimes I guess we have this idea where we want the object to be created, let's just say on the stack potentially. This wouldn't be it. This is an application, so this is quite a heavy object that we saw was constructed explicitly with that create application function. But sometimes you just want to create an object and you want to sort of set all the memory, all the parameters, the application specification in this case, but then sort of leave it dormant until you actually want to do the heavy lifting to create it for real. And create it for real might mean, create a physical window, do something on the actual GPU, because a lot of the times when you're programming, I guess, engines and graphical applications, you might not have the render API initialized yet, but you want obviously to set all your parameters, have the memory ready to go. Then maybe something will happen where Vulkan will get initialized. Now you have a valid Vulkan instance device, all of that stuff, and you can actually start doing stuff on the device. And so because of that, that leads to us having this sort of double, I guess, initialization where the first kind of constructor usually allows you to set up all your parameters first, and then the second phase is, okay, now do the work to actually create this. For an application, I couldn't tell you from memory exactly why this happens. So create application, because I have a suspicion that the create application function that we saw, so that's, if you go back to the entry point, that create application function is implemented by the client. So this is interesting because it's you can see the extern on line 5. So that function actually gets linked in by a specific app. So I guess this is probably the launcher app.
Yes, this is the Hazel launcher app.
Yeah, and so therefore, when you build, because Hazel's just built as a static library, and then when you build an executable or a DLL, you have to provide this function. Otherwise, obviously, this won't link because there's no create application function. So
I missed that extent before.
So that's just a way to force that kind of implementation onto the client, so it can still define, what it does with those startup arguments, the command line arguments, and how it actually creates the application and what kind of application. Because you can subclass application as well. That's not usually done, but there might be some cases for that. I think the reason why it's a derivable class in the first place is because you can have a headless application, I think.
Okay.
Unless that's just implemented straight up because we compile differently. So maybe you don't need that to be obviously set up as a virtual class, since you can just switch out the implementation of application for headless builds. Yeah, so if you go back to that launcher application would be a good example, I guess, with the create application function. Yeah, so what do we do? So so this kind of looks like we would actually, this is doing a walnut application. So let's go to runtime application, maybe .cpp, something like that. So if you find if you scroll down a little bit to create application, then you can see that we set up that application specification. There's a bunch of potential tiering settings. We're setting all of that up, and then we're just returning a new runtime application. Yeah, so I wonder if the constructor of application would actually be the thing that calls in it, because if it is, then obviously I would be a little bit less happy with having that two-stage thing. And it kind of looks like it probably would have to.
So I think when I was looking at this, the only time it's called is in run.
Oh, run, okay.
Which I can understand then why you might want to defer it till you actually start it.
Yes.
And then, because it calls on shutdown at the end. But then I think in that case, right, might make sense to have these as protected, because at the moment someone could accidentally, it's unlikely, but do you know what I mean? You've exposed an interface that you probably don't want someone to actually call. So if you make those, I think, protected, then you could still have that kind of, that two-phase construction effectively becomes an implementation detail.
But also, on init does nothing at the moment in this application.
Oh yeah, well, it's virtual though, so presumably you could.
So what
provide your own
is? I wonder
implementation.
what derives from application. Also, I wonder if I made all these virtual. That's the question. Here we go.
so we've
I'm
got
resorting back to this.
There's a Jolt viewer, which is a public application.
But that's inside vendor, so that would be not our code. I don't
Oh,
think
is that
would
inside
use
vendor?
any
Okay, fine, yeah. So
Hazel
I can't
code.
see anything unless
Yeah.
it's multiple inheritance.
Okay, so
or
it
I've just my grep as
seems
well.
like some comedian has just made all this virtual, and I think we might have to bring out Git blame because I don't remember why this was the case. Yeah, the only thing I could have justified it is maybe like if we had like sort of a GUI application and a headless application variant, but the way that we handled that is just, and I think the net branch which introduced headless builds got merged in like after August, which is why you don't have that. But yeah, with that, obviously, like headless builds are a specific sort of compiler define. It's like a build configuration. And in that case, obviously you don't need, in fact, you can't have any of this application stuff that uses the GUI and render API because they're not linked in at all for headless builds. So that would definitely not be like a runtime derived class virtual situation. It would just be a compile time replacement of the implementation of all of this.
Yes.
So
How interesting.
therefore this is probably wrong.
Okay.
Because the other thing with Hazel is that like the way that the client implements their own sort of custom code for the application is not by deriving application and then replacing like all these things. It's by using layers. And that whole layer system is a way for us to basically be like, okay, I've made like the runtime for Hazel, and what do I need that application to do? You know, versus like the launcher application or like the editor application, because obviously they're going to be different. And the application is really like that core class that sits there that actually does all the behind the scenes work and all the core stuff to actually run the physical like Windows application, for example. But then layers is how you implement your own custom functionality. So therefore, the only reason why you would theoretically derive this is if you really want to change the core so much that you want to change like what shutting down any Hazel application does,
or
but at
initializing.
the core level, not at the top level with the stuff that you've added
So
in the
for
client,
anything-
which would be in layers.
Yeah. So for any application that's then built on top of your new modified core, you would then get that functionality.
Yeah, I guess so. So
It's very flexible,
it is weird.
Hazel.
Yeah, well, it seems this way. But again, like my use case for that would be like if you want to modify it so much, go into the applications, go into application.cpp and do the modifications there. I don't think you need to provide an interface for everything that doesn't. Because Hazel's meant to be like, we try and keep it simple and write it sort of in a flexible-ish way so that if you really want to repurpose it for your own, purpose, then you can just dig into the code and start changing stuff without having to be like provided, some sort of function or interface to do all of it, not in the core. Like just get into the core and change stuff,
Well, that's interesting insight. Thanks for kind of going through a bit of the history for that for me, because like it was interesting when I saw it, and it's kind of interesting to know the backstory. It's totally different now, but something else I saw on this which I think was interesting was so I'm kind of a bit of a, I guess, anti shared pointer person. Won't go through the whole spiel, but like I think unique pointer is generally what you probably want in like 99% of the case. But I think here you have like what would be the one use case for it, because you're trying to put that managed pointer inside a stud function, which has to be copyable. So you can't. So I suspect this is why there's a shared pointer here, right? Because you want to transfer ownership into the lambda, which is in a stud function. Because I think event queue is a queue of stud functions or something.
Yeah. Well, I'm pretty sure the event queue is just arbitrary lambdas that you want to run at some point on the main thread. Where are we? What's this file? Application.h.
This is application.h.
Okay, yep.
Yeah, there you go. It's a pair of
just
balls
functions.
and functions. What I thought you might find interesting is in C++23, this is a solved problem, and you can actually do that. So if you made this a unique pointer, obviously like make share to or just delete it all, or make share to make unique. If you do I think it's event equals stud move event, right? So you transfer ownership of it through the capture, and then you change the event queue to what's now a move only function. You can that move only through the type erasure allows it to contain things which are move only.
Right.
Kind of I don't know if you've seen that or how.
No, I haven't. Like I would have expected that you could have just moved the unique pointer into where you want to transfer kind of ownership to. But yeah, I haven't seen move only function before. But actually, if you go back to that code, to that function, I'm like kind of interested in this because dispatch event, like I don't know exactly what events these are, like if they're the events from our event system or not. I mean, it's sort of templated, so T events could be anything. And it's not like there's no obviously there's no concept or any kind of code here to make sure that it's a specific like derived type or anything. But the way that our event system usually works, if you go to like window.cpp, I think in this version of Hazel, and if you go to like just scroll down to, there'll be all these like event callbacks. Yeah, so like all of these. Yeah, you can see that if you scroll down a little bit, we have like key pressed event, and you can see the way those events are, like they're just created on the stack, and then they're just like, they're taken in as references by the event callback, because there's really no, even though they're derived, like there's no need to like, you know, allocate them on the heap as unique pointers or shared pointers or any of that. Yeah, and this would be the way that, you know, any layer would receive, say, a key pressed event, so it could then dispatch it to the appropriate function and handle it. And so that doesn't involve heap allocation at all. So I'm wondering what those events are, because that there must be not normal
because
application
the function
events.
could heap allocate. Obviously, it's allowed to do like a small buffer optimization, but that's not required. So you have to kind of assume that a std function will do a heap allocation.
Well, yeah, and specifically, obviously, when if you're doing make shared or make unique.
Yeah, well, yeah, you've already got that anyway.
Then, yeah, exactly. So that's more the part that I'm interested in. But again, I have no idea what this. Yeah, and I didn't write this code, but I have no idea. Yeah, but it is calling on event, and on event is called, because you can see it's even having to like dereference the pointer.
Yeah. Yes.
Because on
so
event takes in an event reference, and that also tells me.
I see. Sorry.
That also tells me that
the reference.
That also tells me that it has to be derived from event. T event has to be derived from event because on event takes in an event reference.
Oh, I see. Okay, fine. Okay, interesting.
So this is bizarre, because I guess it effectively, what was it? So it takes it, so it creates a brand new event object with all the arguments, and then if you have dispatch immediately on, then it just calls on event and then dereferences it. Yeah, this is weird. Okay, I'm gonna take some notes and I'm gonna bring some of these up with the team. This is excellent, by the way. This is great. It's like getting,
because I have no context. I have no idea what's. Yeah.
Yeah, I was gonna say, this is like hiring someone to like, you know, do a little sweep of your code and like identify some issues. This is great. You're much better than a static analyzer.
Thank you. I'll put that on my CV.
I'm literally writing this on my pink post-it note.
Nice. Well, because I have no context, right? I have no idea what's like, important or a hot path or critical or something that was written 3 years ago and never used. I just have to take it all as important.
Yeah.
And so I just sort of, like I said, meandered my way through the code and picked out a few interesting things.
Yeah, I feel like this was written, I feel like this function in a very different form, like just the application dispatch event function, was written by me, but event didn't literally mean an event of like the event class type. I think it just meant like, I want to dispatch something, or I want to queue something to run on the main thread essentially. And it probably all it had was lines 102 and 103, and that's it. Just like, you know, here's the event queue, because and then it would just take in probably like an std function or something, like just a lambda, and then it would queue that up for execution on the main thread, and that was it. And then somehow it mutated into this. So I would love to like take a look at this function from like 5 years ago or so and see what on earth happened. In fact, I might quickly do that.
Get my next code snippet up. So I'm still sort of in the application layer. So I find this bit of code here is fascinating to me, because I feel like the layer stack object should own the memory, right? And then you just call like clear on it, and then it would call detach and delete the layers for you. Because I think when you push into them, you kind of take it. Do you take it by raw point and put it in? I'm just trying to find where the layer stack code is now. But this feels very much like it should be like the responsibility of the layer stack, rather than, I pull them all out and then I delete them all. But I don't know if there's some wider context or design decision I've kind of missed through that.
So the layer stack was written in like 2018, I think. 2018, 2019 maybe.
Okay.
And so that's definitely something that I'm surprised that it's still the way that it is, because this was just kind of like, it was, I think it was still written when Hazel and the Game Engine series version of Hazel were like, there was no like big Hazel. It was just Hazel from the Game Engine series, and that was the weekly sort of videos that I made. And this was just part of that. And then obviously, like from that, we eventually, like probably half a year or a year later, broke off into Hazel Dev, we used to call it, which was the big version of Hazel. And then that became like the 3D engine that you see today. So this layer stack is one of those things things where I would be like, it needs a rewrite. It needs a rewrite. I don't know what's going on. I'm surprised that it's working. Maybe it's not. Maybe it's like the source. You know, like you have these issues just in your application and you don't know what the source is, but it's probably like this one thing that you don't expect that's just like corrupting some memory or doing something like behind the scenes that's making everything else like fail. So this would be that. But if you get back to that application destructor, so we detach all the layers and delete them. So I guess you can do layers. You can have multiple layers in your application, and some of them might rely on others. I don't know why this is. I would have expected this to go in reverse, to use like a reverse iterator and go through that vector of layers in reverse and kind of delete them top to bottom, because you create them bottom to top, I guess, and then you would delete them top to bottom just in case you had some dependencies or something you wanted to shut down. And so we're going through all of them and calling, this is like that double, you're saying double init. This is like a double shutdown where we have on detach, which is a virtual function that layers should do stuff in, but then in case they do stuff in the destructor, we're also doing that sort of before moving on to the next layer. And since they're all allocated probably with new inside the layer stack, which is just raw pointers,
I think they are.
Yeah. Which again, not good. I would make them. I just have it. I guess as a vector of unique pointers at this point.
Yeah, that's what I was thinking when I looked through this.
Yeah.
Because you can hand out the raw pointer if you're not transferring ownership to people. If people want to access them.
Yeah. Exactly.
And then layer stack just owns the memory of the layer. Also, I think because it's interesting what you said there, like, oh, it should be like a reverse iterator. I definitely think like if you have like very specific destruction logic, I feel like it should just be in the destructor of layer stack, and then it can reverse and iterate or sort them or shuffle them or do whatever it needs to do.
Yeah, it's definitely weird. I think layer stack was probably also a class that was introduced halfway through writing layers, where it's like, okay, this is getting too complex for us to just have all of this code inside application. Let's move it into its own class and sort of make that class, because it kind of, layer stack kind of works as its own data structure. It's got that, begin and end iterator implementations, which is why we can use the the ranged for loop and everything.
Yes, yeah, of course, yeah. Or you can use ranges with it as well.
Yeah, but I'm just like, if we had layer stack be, because this, I wonder if this was written in C++ 14 or C++ 17 back in the day. But anyway, if we just had unique pointers and we just did layer stack.clear, for example, I mean, you wouldn't even have to. You're in the destructor, so it would get cleared, I guess, implicitly. But if you did that, then the shutdown order for layers might be not what you want. Like it might be forward iteration, whereas you might want reverse iteration, which is obviously not what's happening here, but probably should.
Yeah, I see.
So therefore you might want to actually be a bit more explicit, in which case, I would still have them as probably unique pointers. Again, raw pointers, like I do use raw, and by raw pointers, I mean new and delete. Like I use that quite rarely. Like I probably wouldn't even use it here. It's just for things where it's like we have the new and the delete effectively in the same scope, a couple lines from each other, like we do in the entry point. Like for that, I'm like, I'm gonna use new and delete. Like fight me, There's like no reason to introduce extra like cement, extra text on the screen, for no reason really. It's doing the same thing and it's all visible within a couple lines of each other. But for this layer stack, it's a bit, I'd probably change that.
So I feel like I've so far picked on the bits that are really old, and you're like, oh, I don't know. Like, this is kind of old. So hopefully I'll get to something a bit more modernish soon.
Let's I want to quickly take a look before we move on. I want to quickly take a look. So on my screen, this is the history for application.h. So I'm curious, if we look at the whole file, I'm curious. Okay, so there's that dispatch event function. Let's just quickly find when it was introduced. See, it is quite old. I'm in 2022 here. Oh, okay. This is what I was thinking of. So we had this probably queue event, and then we had event queue in place back, and this is not thread safe or anything. And that would basically
forward on that funk as well
to that event queue. Yeah. So that was merged in, it seems, by Peter in 2022, and then that's so weird, like this history, because it's like then it deletes something that wasn't actually present. Then suddenly it's
phantom.
Yeah, and then it's like this, but I don't know.
Was it just a git merge issue then that it kind of came back? Like, should it even be there? Does anything even call it?
Oh, I don't know. That's a good point. I'll quickly have a look. It seems to.
Okay.
All right. So we have all these scene events. Yeah, I didn't write this. I'm not saying that as in I'm shifting the blame. I'm just saying that I don't really know what this does, but I guess we have.
Yeah, that's fine. Like, I think that's inevitable with any project where you don't write every single line of code.
Yeah, so we just have like, I guess when the runtime starts, so when you hit the play button in the editor, or if you're in the runtime and you're running the game, it'll dispatch like certain scene related events, like a scene pre-start event, which we have all these scene events. Yeah, I've got no idea what this is. Let me quickly take a look at that as well. I'm learning so much.
I do like your commit message that just says huge commit.
Yeah. So that was also a Peter thing back in 2022. Just added this, and then Jim
So
kind of
blame him then.
improved it. It seems, with that. Yeah, informative. We should do this more often.
I do like a bit of code spelunking.
It's fun learning the history and the and everything of your own
It provides a lot
code
of colour
base.
to it. Well, it's such a it's a massive code base. Do you know what I mean? Like it's fascinating.
And because
There's
it
obviously
dates
a lot of
back 7
history.
years. There's so much.
Yeah.
Oh, this part. I hate this part. I hate the whole enable IamGUI like runtime switch thing.
I only have like one thing on this,
Yep.
and it's just that capturing this via equals is now deprecated. So at some point you will need to change this to this, otherwise it won't compile. I can't remember which version, 23,
right.
I think it was deprecated.
IamGUI,
so it's just something I saw when I went through.
The way I'd write this today would probably be like IamGUI layer equals M IamGUI layer in the Lambda capture. Because IamGUI layer is probably just a pointer. Is that just a raw pointer, IamGUI layer? I have a feeling it is.
I've used IamGUI before, and I think it's a very C-like.
No,
API.
well, this IamGUI layer is that's an instance of,
is this yours?
Of a Hazel class. So if you can get to the definition of that, it's just a raw pointer. So that's probably also bad. And also, if that was just a raw pointer, I would just capture the actual raw pointer by value. I don't really like capturing this or, kind of larger things. I like to really be quite narrow scoped with my Lambda captures.
Agreed. Yeah.
Just so that you don't accidentally end up writing stuff that you shouldn't be touching. You really think about, okay, I am reaching for this. Because obviously a lot of the times when you're doing Lambda stuff, like in that case, it's actually going to get executed on the render thread, which in the editor, where it's still kind of sort of single threaded, it's not single threaded, but the main thread runs the render command queue at the end, so it just gets deferred. But in the runtime, so like when you build a game and you ship it and you're playing it in the runtime, there is a render thread that's running like one frame behind the main thread. And so obviously you have to be kind of a bit mindful, especially if you have raw pointers, of what you're actually putting into that render thread, because what's the lifetime of that look like? And that's
Is that a Vulkan thing? Is that because you're filling the command buffers from the previous the next frame?
That's
so
just
no
a game
contention?
engine architecture thing. So that's been around from the OpenGL days and everything. Like it's especially important probably for OpenGL. I think with Vulkan, it's, even though render threads are still quite common in the industry, Vulkan is much more, because Vulkan itself can run on different threads. Like you can multi-thread, creating all of your command buffers and everything.
Right, okay.
In Vulkan, you can just set up, like ideally you'd probably have a job system that just, kind of distributes the work across all the available cores. But back in the OpenGL days, OpenGL had to run on one thread, and sometimes it had to be the main thread. Like I remember on some Android devices, like they really wanted it to be the main thread, meaning like the kind of default application thread.
Yeah. I've heard this before. This is
which meant that we actually, like back when I worked on EA's mobile engine back in those days, we would actually start a main thread. So instead of starting an extra thread that's like the render thread, you'd start the main thread because the default initial application thread would have to be the render thread because of some of those Android devices. But otherwise, you would spin off a render thread, and that way OpenGL is locked to that thread, and you can obviously do all the OpenGL related code on that thread while already building up like all the application data and running the scripts
that makes sense.
Logic for the next frame on the application on the main thread.
Yeah, that makes sense. I think my next notes were the renderer, but I have very few. I'm more just interested in the renderer. This is a very where am I? Like it's a very C-like design. It's just lots of sort of static members with like no state, and then the C++ file or the CPP file has like static data at the top. I think it's just kind of a curious design. I'm kind of curious like what the rationale for that was and like how that arrived to be.
Yeah, so I would say that the static data that it has, like this class probably shouldn't have any static data unless it's like maybe debug related stuff. But the idea with renderer is this is just an interface sort of functions that do specific, like they just control the actual render API almost. So there'd be functions like, renderer, probably like render mesh or something, which is quite a high level function, but it would take in everything. So it wouldn't actually have any state. It would just take in like the render command buffer that you wanted to record those commands onto.
Right, okay.
And it's just a clean way for us to actually sort of record what we want to do from Vulkan in this case onto like that command buffer. A class like scene renderer would call, renderer begin render pass, and then renderer render mesh, and then renderer and render pass.
That makes
and
sense.
It's sort of all defined like this statically just because it looks really clean from the calling code from the client. All of these, I mean, we've got like a cache here. The problem with this is, it really is supposed to be stateless because I mean, I don't know, maybe some state's okay, but it's ultimately supposed to be stateless because this can be like, you should be able to call these functions from any context, from any thread, because they're just supposed to be functions that do like a bunch of work, you know?
The basic helper functions were utility functions, which presumably just drive the graphics API, which is itself a C API.
Yeah,
that
and
makes sense.
they're just a high level abstraction over certain primitive sort of functions that you'd want your render API to do for you. The other thing is that like the actual implementation though would be, I don't know if it's still like this. Oh, no, that's in the render. That's in the new renderer branch. I think in this version, it still uses a base class called like S graphics API or something, or that would be the name of it in the functions.
S render API.
S
here,
render API.
Static, one of these.
Yeah, that's right. And then you'd have like OpenGL render API, you know, Vulkan render API, because you'd have all of those. But obviously, for us to call those functions directly, it'd be quite messy from the user, from the client code. We'd have to be like, you know, get render API. Like it wouldn't be as clean as just like renderer, render mesh. Or renderer
makes sense.
So that's why we have this like static wrapper over it.
And like I said, with that context, that makes a lot more sense. And like I said, I didn't drill too much into the renderer stuff because like I had a brief look because I was curious. I was like, that was a lot of VK something ext2, and I was like, okay.
The other thing is that in the new renderer, so in renderer 2025, where we use NVRHI as like the backend and the abstraction layer over the actual graphics APIs, this renderer class, this is like everything's actually implemented here. So if you go right now to like begin render pass inside this file, you can see it just like it's just a wrapper and it just calls into that. But in the new version, it's actually here, the code that does this, because it's not using a specific API, it's using NVRHI, which
so you wrapped their wrap.
Well, no, it's because NVRHI allows us to actually do the rendering. So basically, everything that if you go to begin render pass inside Vulkan renderer, jump to that, for example. So it'll be Vulkan renderer.cpp and then begin render pass. Not alt.
Render pass hold?
Alt. Yeah, that shouldn't be there. We'll cut that out.
Pretend we didn't see that.
Yeah, so all of this Vulkan code here that you can see gets submitted to the render thread, all of this Vulkan code, that's replaced with NVRHI code because the NVRHI is now the abstraction layer for that. So NVRHI is the render API agnostic API, and then it would then call into the equivalent sort of Vulkan code. So we're able to express all of this in NVRHI, and that obviously eliminates the need for us to have, you know, Vulkan render.cpp being a subclass of like, you know, render API or renderer API, and then having the renderer class statically wrap that and call into that. No, it just does the NVRHI stuff directly in renderer.cpp, which I think is a lot cleaner. Because we've just shifted the kind of abstraction point, essentially.
Yeah, okay, no, cool, that makes sense. I don't think I had a huge amount left to say in renderer. Oh yeah, I feel like this, I'm curious about this, because I feel like this should just be a vector of uint16Ts, but I don't know, again, if this is your sort of like new and then I can see where it's going to be deleted kind of thing.
Yeah, so what is this? Like, so this is inside renderer data.
Yeah, one of the big functions.
This is also, I think Karim wrote this.
Init, right at the bottom of init.
Yeah, so this is for the Hilbert lot. So this is probably for like, it's probably, for like ambient occlusion or maybe screen space reflections or something to do. It's for a render technique. Because you can see it creates a texture from that data and it's just generating data.
Yeah.
So I wouldn't write it this way. I would probably just 64 by 64. I mean, that's quite a lot to probably just stack allocate potentially, right?
Well, I mean, I'd just use when you just use a vector of this size.
Yeah, you can just use a vector. Well, yeah, because usually if it was like small enough, I'd just use an array.
Oh yeah, of course. Yeah, no, totally.
But that seems sizey, so I'd probably... Yeah, I just use a vector. The thing is, like, so what happens is you can see it gets passed into texture 2D and then it gets wrapped in buffer, which is just like a Hazel kind of utility class. But that's also crazy because it's the size of the buffer is being explicitly set to 1, like as in 1 byte. So
yes.
I don't know what on earth is going on there. Again, I didn't write this code, but I'm going to have like a nice team meeting after this, I think. No, but just Cherno's calling an emergency meeting. Everyone must attend.
Oh dear.
So, because what would happen is, we pass in that buffer directly into Texture 2D with the data we want to upload to the GPU, but I'm pretty sure the Texture 2D, if it's planning to defer that to the render thread, that actual transfer operation, then it would copy it into a local buffer that obviously it owns, so that in line 300, when we delete it, the render thread obviously still has that data. In which case,
has a copy of it.
In which case you don't. It's not like you need to allocate it here, and then it will later get deleted by the texture2d class when the upload's complete. Like, it's all, if anything, it gets copied locally. So that would mean that there's no reason not to have this as a vector.
Okay, cool. There's another class. So class I was really interested in is ref.
Oh yeah,
because this is basically, from what I can tell, correct me if I'm wrong, this is like a mix-in to get shared pointed or shared ownership kind of semantics. You inherit from ref, and then your class is effectively has the reference counted. And then I think it uses atomics. Like, it's very similar to like what I would consider reasonably standard like shared pointer implementation.
Yes.
I'm really like, I think I have two questions around this. Like, one was like, why the usage, like the shared ownership kind of like model in the first place, and two, why write a mix-in rather than just wrap everything in shared pointer?
Okay, so this is something called an intrusive reference counting system, and an intrusive reference counting system, which I believe shared pointers have a way to set that up by deriving from some sort of shared pointer class.
Make shared from this or something like that.
Yeah, something like that. But you have to actually make sure that every class is, I guess, derives from a certain type of shared pointer.
I think it's make shared from this.
Yeah, right. So that's the actual name of the class that you derive from.
Yeah, and I think it might be CRTP.
I've never
as well.
used
I can't
it.
remember.
Yeah.
I've never used it.
I've never used it, no. So let me answer the question about why the shared pointer ownership situation in the first place. So the reason why is because it's really because of the render thread. We have a lot of lots and lots of scenarios in the engine where something might be created and used by the main thread, but then the render thread also needs access to that memory, essentially. And since they're two different threads, we don't really know who will finish with it last. And so it's sort of like they both need access to it, and they both might be using it, and we don't want to obviously delete it before we're sure that everyone is done with it. And so this sort of reference
last
counting...
one out turns the lights off.
Exactly, yeah. So this sort of reference counting system is basically something you'll find in every single game engine. If everything was obviously single-threaded, I think you probably wouldn't need this because it's very deterministic what will finish with it.
Yeah.
But when you have multiple threads, and it doesn't just have to be the main thread and the render thread, it could be like the audio thread might need something, or like the asset loading thread would also be like loading assets in the background, and who knows like who finishes with that asset last and needs to free it. Because it's at the end of the day not deterministic how, like, what order the threads will execute in.
Yeah, of course.
You basically need a reference counting system to make sure that you're not killing something before its life has concluded.
Yeah, I think that's like the one use case I've sort of heard of shared pointer. Like, I don't think I've ever written a lot of code which has ever needed it, because I think when I've been in a situation like that before, I've been able to just kind of allocate everything beforehand and then just pass raw pointers around and then clean it up at the end.
Yeah.
But yeah, I guess if you've got like a very like turbulent lifetime of objects, then that kind of makes sense.
I guess the reason why this was written, so I did write this, so I can this was like the first time I think I've said that.
There's no hiding now.
Entry point also wrote the code that we looked at, but I just didn't want to use like the whole make shared from this or whatever on earth that system was. And this is useful because like for debugging basically. So I have a lot more control. Like if there's some objects that are acting weird, I can just slap in some debugging code. It's such a core kind of system, this is basically how most objects in the engine get allocated and used, and being able to chuck in some tracking, being able to, even something like isolating objects of certain types. I could just, put in a concept, for example, that just says like, only allow this type, and then, or like only allow everything except for this type. And then I can easily see in the code base, like, okay, where is this happening? I mean, it's a bit more useful for derived types and like virtual stuff, because obviously if they're just written out, you could just search the code base for it. But stuff like that basically. And the reason why intrusive reference counting in the first place is because there's lots of scenarios where a class itself has to submit kind of itself onto the render thread. So if you go to like... maybe Vulkan vertex buffer.cpp as an example. Yeah, I mean, even there, but if we scroll, well, yeah, sure, you can look at the constructor. So you can see that like we want to run the actual vertex buffer allocation and creation code on the render thread, but clearly it needs access to this instance, like the current class.
Yes.
And if you if you go down a bit more as well in the file, you'll probably see that everywhere. So like, set data, for example, needs to call. So the RT prefix stands for render thread. A lot of people, think it stands for ray tracing, which is funny. But so that basically means that function is designed to be called from the render thread. And you can see that obviously in line 116, where sort of essentially calling the function itself is called set data, but then we call the render thread version of that function on the render thread, and it keeps things kind of clean.
Okay, yeah.
But we obviously need access to the instance because that's what we're sort of doing. And that also, like, there'll be some scenarios in which we want to do something like super transient. So probably not with vertex buffers, but maybe with like a texture or even a compute pass. Like we might want to just all in one function, create a compute pass, set up some resources like textures, dispatch the compute pass for execution, like execute that compute shader, and then like we're done, just free it, delete it. We've got our texture generated that we needed to do. And so that the lifetime of like that compute pass and all the compute stuff that happens, and maybe like some of the resources that we're reading, you know, that's all like within the scope of that function. But then we can't have, you know, the compute pass or the texture or whatever die before it's even completed execution on the render thread, because that gets done the next frame. And so therefore we need it to kind of submit itself to the render thread. And then obviously by doing that and copying it, you know, by value as it is on line 114, when we take an instance, it's obviously incrementing the reference count, and then the render thread can be the last one to finish with it. I'd probably like nowadays, I used to write it like line 113, you know, where we just have, you know, ref Falcon vertex buffer instance equal to this. Now I might do like inside the lambda capture instance equals, you know, ref, but like, I don't know.
Yes, ref
this also keeps it sort of, the lambda capture's a lot clearer because you're not having this huge like line that says
it can run away from you.
Ref Falcon vertex buffer or whatever. The what? Sorry,
I said they can run away from you, like the captures.
Yes,
if you start,
well, exactly.
No, I think that's perfectly fine.
Great.
That's clear.
Instance
That's
size
kind of
offset.
obvious to me reading
Beautiful.
it.
Yeah.
Yeah, it's nice. Yeah, no, I like it. What else did I have to say in ref? I'm not a big fan of C-style casts, but that's just maybe like I would potentially UB this anyway, right? Because depending on what you're casting it to, so I would probably just be explicit with the reinterpret cast.
Yes. So this might be, I don't know if I should announce this here, but I feel like I have finally lost the battle with myself as far as C-style casts go, and I feel like I have secretly off camera been writing like static cast and reinterpret cast and whatever.
The correct cast.
I don't remember why I made that decision. I guess I like the idea of being more explicit, even though like you can just static cast everything, and it's like, you know, you don't have to use reinterpret cast, right? Like static cast will allow you to
static cast checks that there is a valid conversion, so you get the compile time safety, right?
Okay.
Yeah. It will check
still learning about this.
If the language knows how to do the conversion, like float to int or whatever, it will do it. Or it'll also check all your overloaded or custom provided cast operators within the types, and then it will emit the code to do it. Whereas reinterpret cast is just like, this pointer is now this type.
Yes.
Like, good luck. Hope you don't violate the strict aliasing rule.
Well, over here at the moment, obviously I would replace this with like a reinterpret cast, but if I wrote it out as a static cast, would that be a compile error?
I think it depends on what the types are.
Okay.
What T and T2 are, and whether there's a known static conversion. So you can static.
I see. So if it's like, if it's like
static
a derived
cast anything
class,
to a void pointer. Yeah.
If it's
or a
essentially
derived class, and
sorry, go on.
No, I think you're right. You can static cast between derived types, like
like a dynamic cast
hierarchy. Yes, but obviously it won't do any RTTI to check if it's valid or not. It'll just become it. And then I think you can. I think you can always static cast to a void pointer. I think. So that might, whether that's what you want or not, I don't know. Whereas reinterpret cast is literally, it basically doesn't emit any assembly. It's just like, this pointer is now this pointer. Like, you know.
So if you go to buffer.h as an example,
I have some notes on buffer.h.
Oh no, I feel like I've written that a lot of times. But if you
one of my notes is like, a lot of C-style casting here.
Yes, well, that's the old Cherno, apparently, as we're learning today. And then, like, next video will be like, nah, screw this, I lied. I'm still sticking with C-style casts. If you go to the as function, which should be a bit lower. So data would maybe be a uint 8t. No, it's probably just a void pointer. So if I have
a void pointer,
if data is a void pointer, and I obviously want to cast it with .as to whatever, I'd have to use reinterpret cast.
I think so, yeah.
Okay.
Because I think you're probably doing reinterpret cast is like you're kind of stepping over the type system a bit, and you kind of have to opt into that the bear trap that you are laying for yourself.
But it compiles into the same thing, right? It's just the compile time check ultimately.
But I mean, you're technically could be invoking undefined behavior, right? Because you can't have a pointer to an object that was never constructed, and you can't have pointers of two different types to the same memory address. Both of those are UB. So you are kind of setting yourself up potentially for violating either of those.
Yes, but this is mostly used for like, you just have a buffer of data, but maybe you want to treat it as like uint32t because you want to iterate over it in 4-byte increments,
Yeah, but if you dereference that uint32t, you are then UB, right? Because you've got access to a uint32t that was never constructed in like the abstract machine.
Right. Really?
I believe so. Like, if you go to the CP ref for reinterpret cast and like control F undefined behavior, it's like.
But that's
like, surprisingly is you can reinterpret cast any object to a byte pointer because that's the only way to do object serialization, right? To access the underlying bytes. But you got to be real careful going back the other way. I think like technically the correct way is to default construct the object that you want and then mem copy the bytes over because that's fine.
But if we're not talking about objects, if we're just talking about primitive types,
I think they're still classified as objects, right? Because it's still sprung into life somewhere that the abstract machine has never kind of seen. Like they still effectively constructed.
So interesting. I should like look into that because that's.
But C++
because that is done all the time, like in production code.
I can't remember the exact syntax, but C++ 23 has something like start lifetime as. I think it's something like this. No one's implemented it yet, which is really annoying. But it basically solves this issue. What it will do is it will internally, I believe, it will default construct T and mem copy the bytes over, but then the compiler will probably just elide all that anyway and just give you. It will basically, originally when they proposed this, it was called std bless, and it basically blesses your type as the new type, and it allows you to use it as undefined behavior.
That's crazy.
I know. But yeah, anyway.
But that seems like so much overhead and so much like, extra stuff. If it's like, okay, I have like, this memory layout of bytes, but I want to, transform it or use it as,
it's
something
kind of like
else.
UB in the sense that everyone does it, so it probably actually works. But I think if you're going to go down, I'm sure someone in the comments who's a language lawyer will be like, oh, actually, section 12.3.4 clearly states this, because I'm not a language lawyer.
Is it because those types, like, it could come down to like memory order or like padding or like whatever else? Or why does it matter? If you just have a tightly packed stream of bytes, why can't you just treat it? Like, I get it. Like, if you had like a struct and the packing of the struct would be like not standard or it had like some alignment, I could kind of see how maybe that would be dodgy. But yeah, going from essentially like I've read a buffer of tightly packed memory off disk, like from my disk into my memory, and now I want to just iterate through it as 32-bit integers or 64-bit integers and then kind of deal with it. I
think reading from that pointer is technically UB because again those objects have been created. But I mean, I will go and check all this afterwards, and I'll send you a message whether I was right or wrong.
This is.
But it's one of those real like corner cases of the language, I think.
Yeah, right.
But reinterpret cast won't save you. But at least it's more obvious what you're doing.
Yeah,
what you're doing.
Yeah. Huh.
I'm generally fascinated by this class in general, actually, because I don't like. I'm curious why it's not just like a vector of bytes, like because you do like an allocate of some number of bytes and mem copy it in. Like, could this whole thing not just be a stood vector of
that's optional. Like, you don't have to use allocate. The allocate, like that, that allocate that you saw, that's in the copy function.
Oh, I see. So where do you?
So if you look at the constructor just takes in.
Yeah.
It doesn't. This class has no ownership at all. It's just a view. It's kind of like a view.
Interpreted that slightly. I see now. Yes. Okay. Yeah. It's basically a
range.
Almost like a stood span.
A span, sorry, yes. Yeah, it's basically a span. This was, I think, when was spans introduced? Yeah, so this predates spans.
Yeah, okay. No, that's fine. I think because when I saw allocate, I was like, oh, this must be owning, and then because there's also release, because release does delete, right?
Yes, but that's obviously that's explicit. Like, you have to call that. It's
explicit,
not,
okay.
So it doesn't actually own it. It's just a way for us to delete it. But this is just kind of like...
my question was like, why is this not in the destructor? But I get it now.
Yeah,
I think
because it doesn't own. I think someone, probably Jay, introduced, if you go down to the bottom of this file, I think there's like a safe.
Yes.
Buffer safe, which does that, which is... Yeah, I didn't write that part.
Actually, shouldn't this have a copy constructor disabled?
Yes, it probably should have a lot of things.
Okay.
Honestly, it probably shouldn't exist, I think. But
okay.
There was probably some case in which it was necessary.
Yeah. Okay.
Better, but it's just basically like I need to take in, or I want to work with a pointer and a size, but I want to wrap that in some, utility that makes it look nicer and gives me some more functions to work with that data. Basically, that's what
Yeah.
the buffer class is. And it's great. It's great. That's why we copy it everywhere. Like we pass it by value and everything, because it's obviously
it's not
just
owning. No, yeah, it's absolutely
Yes.
exactly like a span. I think if you didn't want to use span, I would definitely recommend trying to expose a lowercase begin and end, because then it becomes a range, and then you can you can pass it to all the ranges, outposts, and stuff like that, and it just gives you a little bit more flexibility on it.
That's a good idea. Yeah.
I think I'm going to jump somewhere totally different now, because this is where I started sort of just picking random files and going around. I'm a big fan of string view. Love string view.
Yep.
Here you're having to make a copy of it to do the sort of the setting and stuff.
Yep.
I don't know if you do it for the
I didn't write application settings.
so specifically here. Oh, I mean that'll.
People think I'm joking, by the way, but I'm not. People are also realizing that I've written like 10 lines of code in Hazel. No, the renderer and most of the core stuff I'm totally responsible for, but this, I don't remember this. Actually, maybe I did write this.
I was just saying, because with unordered map, I can't remember when it came in, like 17 or 20, they added the ability for what they call heterogeneous lookup. So it means when you look up stuff via a string view, it won't internally allocate a new string, because you can compare a string and a string view without doing an allocation.
Yeah, yep.
But at the moment, like you have to allocate a string.
Yes.
I mean, I'm sure this is not used in like a hot loop.
No.
But you can, if you use heterogeneous lookup, which is just a little bit of templating magic around the hash function.
This is insane, though. I definitely wouldn't have written this, because get int and get float, like we're reading data. Like that data should 100% be in the exact format. I mean, this is having to do a conversion into float and int, so I guess that makes sense. Like it has to.
Oh yeah.
But I'm definitely like, I feel like if I was writing this now, I would try and sort of, when you load the application settings, I would try and have it set up in a way that you can access the actual float and int and whatever you want. Like I would do that transformation during the loading, so that when you're in the runtime and you're trying to just simply access the data, that's the optimized
that makes
path.
sense. Yeah, pay the cost once.
Yeah, it's like, it's weird to have this, because this is crazy, because I could definitely imagine someone calling these functions like, every frame, like it's normal.
Yeah.
You wouldn't even think that like querying application settings would have all of this cost associated with it. So
yeah, it's like it does a string allocation and a whole bunch of other stuff and casting.
I'm writing that one down as well.
I do have another one that you might want to write down afterwards. So I'm now in animation, so I've obviously jumped quite far around. I think you have a resource leak here.
Okay.
Because if animation is already constructed and you're move assigning over it, you just take the pointer, but you never release M data. Surely you should have something like this in here.
So what's M data? Like what type is that?
It's a void pointer. So who knows?
But
animation does own this. There's a comment there.
Okay. Can we go back to that? Okay. That's true. Because obviously, what on earth happens with M data?
Yeah, it leaks, right? It's gone. You've
yeah, it just takes over it. It's almost like this is designed to happen before the allocation or something, but it's clearly could happen halfway through the lifetime.
You could have constructed an animation and still moved another one over the top of it.
I'll let this is Jim's domain. I'll let him know.
Okay. I'm learning about the whole team.
Yeah.
Maybe not in a way they would.
Everyone except for me.
Like
yeah. Okay. That's the animation CPP, right?
Yeah. I think that's the only one I had here. Having done skeleton animation once, I understand like the horror that goes along with it.
We have our own kind of system for that as well.
I was just wondering if this could just be a unique pointer or a std any or something. But again, I don't know the wider context of why it's a void pointer and what else it could be.
Neither do I.
But you might have had some safety through just using that. What else was there? And then I went over to skeleton. Stuff like this, like I would just replace with ranges, but I don't know how. I haven't seen any ranges sort of in the codebase yet, so I don't know if you've kind of got around to sort of integrating those or using those yet. But just stuff like that, something like that could be just.
Yeah, it varies by author basically. Some people will write code with ranges in Hazel, some won't. I don't know. I also don't mind being a bit more explicit with this. Like, clearly what even is the bird name's
got static cast, so that's something.
Yeah, I mean, obviously we're trying to get the index though. That's ultimately what the function's returning. So how would you do that with a range?
You can put me on the spot now, aren't you? So it's auto. I guess what bone equals m. I suppose stood ranges find if m bone names auto e dot. Is that e equals name, something like that?
Yeah.
And then you could just do like return bone equals stood. I'm a big fan of like the pure function versions of ranges of like end and begin, but I don't think that's a commonly held view. whatever. Do you know, on the ternary, then you could return it, or you could return
Yeah.
your null index. Or, I mean, I would probably use an optional, but I don't know the full context of this and whether that was. I don't really like random numbers
Yeah.
representing like no state.
Yes.
But again, I don't know like when this was read and what
null
the
index,
the
yeah.
sort of theory was.
Yeah. Well, I don't know. I think in this case, I'd be probably lean towards
It's going to be compiled to the same code. I
leaving
really
it
don't
the
think
way
it's a
that
deal
it
breaker.
is. Yeah. I just think
Yeah.
it just complicates the actual look of the code for probably no real benefit in this case. Sometimes like, it might make it look cleaner, but in this case, I think like, like a junior programmer could easily come in here and understand everything.
I think you'll have a bit of an eye opener when you review my code, because like if I can write it as a range, like I've written it as a range regardless of whether a loop was better or not.
Yeah.
Oh, there's another actually interesting one I found. So back to Hazel Gooey.cpp. Interesting. String view is not guaranteed to be null terminated.
Yes.
It's just a pointer and a size, and you pass it into what takes a const char star, and I think you're probably okay in here because it's not exploded. But that's why there's no .cstra on it. It's only .data.
Yes. Yeah, that's true. Also unfortunately something I didn't write, but I don't know. Yeah, like I string views are cool and all, but I do find myself taking in just const string references most of the time, especially because if it's already a string, it's like, what does the string view do? In fact, I guess, if anything, probably a little bit of overhead, right? Because it's got that size variable, which you don't really need. Like, you don't really need to transform it into that type. I'm sure it's like very negligible, like in the grand scheme of things. But if you go from a string to a string view without any reason to do that, because then later you use it as a string, or you just want the buffer, like in this case you do like string.cstring, then it's like, why introduce that
I think
conversion?
the advantage is if you were calling this and you had different places in the code where you're calling it with either a stood string or a string literal, then you kind of it's zero
for a
overhead
string literal,
both.
100% that makes sense, because obviously then you don't have to
allocate every time
construct a
on
string
it.
out of it.
But I guess if you know it's going to be a stood string everywhere, then I mean, like a lot of this is subjective, right? Like this is just I'm just sort of saying things as I see it.
I guess it's just like, to me, obviously draw field value, that will never be a literal, because like value is definitely data. Like value is not
right. Okay.
If this was like, draw label, then obviously it's common for you to type out a label as a string literal, but value is like always, and you can see there's like all these data types, storage, get type, bool, none of this stuff's going to be a literal at the end of the day. It is a name, but the name would also be deserialized or something. It would be, you're just referring to existing data in memory, in which case that would probably be stored as a string, or like, it would be stored as a string. There's no other option basically. I guess it's just fine tuning it a bit.
I just sort of saw the passing it to a C const char star. That's sort of just the first thing my eyes saw.
No, it's a good
because
point.
I've used it in Gooey before, so I know it's quite C-like.
Yeah, it's a good point. And I would probably change this to be a const string reference in this case.
I think they're trying to standardize a C string view, which guarantees the null byte on the end, but I don't think that's.
But that's also like I guess that's. Like, to me, that's just this needless layer of operation that has to happen, because it's like, okay, I'm giving my string to a C string view, so now it has to make sure that it's like null terminated or whatever. I guess it could just trust that if the source is a string versus like a string literal or some buffer, then okay, that's like fast path, don't even worry, it's definitely null terminated. But at the end of the day, it's like, okay, you're going from one type to another type, which, is fairly lightweight, but also what's even more lightweight is not doing that.
Yeah, again, I think in my mind, it's more like the previous point I was saying, where it's like I kind of like higher level vocabulary types, which I kind of I can generic. I don't have to. It will accept either a literal or the real thing. Yes. I don't have to worry too much about it, and I know I have some guarantees on what that means, kind of going on the other side. But yeah, like you say, if you know the whole code base and you're optimizing it, it's not part of a public API.
Yes.
Then sure, I would agree that it's not like a high priority code change to make everything a string view.
Yeah, and I think that like, even if it was public API, because the only time this would probably be an actual literal is if someone's like testing this or like putting in some debug code, in which case it's not the biggest
No, like I said, it's part of your interface.
And also you probably like field names aren't that long, so it'd probably be small string optimized, so there's no heap allocation, and it wouldn't be the end of the world if you passed it in as an entity string, but it was a literal. But also like what would you do with this current code? Would you just ensure that string view was null terminated by checking it or something, or what would you do?
No, so I kind of quite like sort of narrow contracts. Do you know what I mean? So in the sense that there would be some sort of comment or documentation which says, this must be. Oh, sorry, no, I see what you mean. In this specific case, I would take it by const string ref if I knew I was going to pass
so
it
you would
into
also
a
do that.
CAPI. I wouldn't kind of blur those lines.
Even if it could be a string literal.
Yes, I think I would make it part of the API. If I knew internally that I had to pass it onto a CAPI, then I would make sure I accepted it in a form that was conducive to that. Or if I really wanted to use string view, I would then allocate it myself. I'd take a copy inside and then make it. But then at that point, I'm just doing a load of extra work. Like
Exactly.
You say. So I would probably not use. I think my general view is I don't use string view if I know it's going to go anywhere near a CAPI.
Yes. Yeah, okay. And also, like, the other issue is that if you're doing that transformation, that allocation and everything yourself within this function, then you're obviously, you're taking that control away from the calling code, because the calling code a lot of the times might have already done that, or like it's in a perfect format, and then you're passing it to a function that does stuff and has that overhead for no reason. So
yeah, I agree. Yeah, they're paying for something they're not using effectively.
Exactly.
Which is probably the one thing C++ programmers can all agree on is to not do that.
Yes.
Also, I saw this as well. I don't know if there's a new C++20 trick you can use using enum data type here, and it brings all the bools into just the scope of the switch.
Oh, great.
And
Cool.
just drop all that.
I didn't know that. Yeah, that's nice.
It's one of those like nice things that it just is slightly less typing. But yeah, I just saw that and I was like, oh, if you hadn't heard of that, you might find it useful.
That's cool.
So now I'm on to the audio node processor. It's a bit of a detour. Curious why you pass a shared pointer by a const ref, which kind of seems to be not the point of a shared pointer.
That's a very common thing that I do a lot, and the reason why is performance. Because if you aren't actually taking ownership of it and you're just like passing it around, then this prevents the atomic increment.
Shouldn't you pass it by reference or raw pointer then? Like just pull it outside of the shared pointer if it's non-owning?
No, well, it is owning eventually. Like when we put it into like that destination EVs thing, like that's probably a vector of shared pointers or something.
Yeah.
It's just that we don't want it to copy into this function and then copy again into that.
Right.
You know,
okay.
Same reason why in a for loop, I would also, if you're doing like a kind of a for each loop or a ranged for loop or whatever the proper term is,
range-based for loop.
Yeah, you would do like say const auto reference that pointer if you're iterating through a vector of them, because obviously if you don't, then it's copying the shared pointer every time, and that's doing all the atomic incrementing and decrementing and stuff that you don't want to do.
Okay, that kind of makes sense. I think I would probably take it by value, then move it into the vector, but I don't know if that. I think that's largely I think that still only then does one copy, because you're still doing a doing a copy.
That would probably do one copy, but I feel like it's probably easier just to add a const reference or something than adding like move and not forgetting to do that.
I think it's like, because I very rarely do const ref share pointer as the interface. I think if you just gave me a header file with that, like I don't think I know necessarily what that means. Whereas if I saw that it just took it by value, that I know it's going to do at least one increment. It's probably going to extend the lifetime.
Ultimately, we're very inconsistent with this. Like sometimes we'll do it, sometimes we won't. Like same situation with the ref class. Like we take the ref class obviously like in a lot of places by value, but it's still doing an atomic increment if you copy it.
Yeah.
So that's probably also something that we shouldn't do. And again, like the overhead of an atomic increment is not terrible, but it's also like, it's an atomic increment. Like it's not nothing. And it's, if you can avoid it, especially in trivial cases like this, where you're probably doing stuff like this a lot, and by stuff like this, I don't mean literally output event add destination, but just passing in shared pointers or ref instances into functions. Like that obviously happens often throughout the code base. I think if you just remove
and then
all of
later
the
on
copying,
takes ownership.
Yes. So you're saying that if it doesn't take ownership, if it's just like a read-only thing for the scope of this function, you would just pass it in as a raw pointer?
Or reference, if I knew it wasn't null. Yeah. I would just do my shared pointer, dot get or star or something into it. It's kind of my philosophy is like, I still think raw pointers are useful for like non-owning, peak operations.
Yeah, the only issue I have...
Style.
The only issue I have with no, I mean you're right. Obviously, if the scope of that of the usage of that variable is clearly defined here, then that makes sense. One thing I don't like that I see a lot in the code review series is people will do that, but they'll kind of they'll grab like the raw pointer from a shared pointer or a unique pointer and then pass it into like the constructor of a class that then stores it as a member.
Yes. Oh,
And
yeah. No.
and that's always like, I'm always like, yeah, that needs to
No,
be
I agree.
either a strong reference or a weak reference, like a weak pointer.
Well, it's all about ownership semantics, right? So
Yeah.
in my mind, pointers are now in sort of postmodern C++ or whatever, like pointers are non-owning to a certain extent. Do you know what I mean? Like if I see a raw pointer going around, I'm going to assume that
it's
that
like
is
a
not
string view.
participating in the lifetime ownership.
Yeah.
I just had a couple more bits to go that I thought were interesting. One was, so now I'm over to Windows thread.cpp. I find this line really interesting because this only works for ASCII strings.
Right. Yeah. Wide strings. I hate wide strings. Yeah.
If you had multi-byte character, like multi-byte UTF characters in there, like an emoji, like that is probably not going to do what you think it does. But again, I don't know if you're going to be setting your thread names to be like emoji poo.
Yeah, probably not, or like non-ASCII characters like Cyrillic or whatever else. But the thing is, like, it's got to be because set thread description.
It's because this only takes a wide string.
Yes, because it's the Windows API, and unfortunately, a lot of the Windows API does that. But
Yes.
I also don't know if that's.
I spent a lot of time doing Windows programming.
Yeah. So what would you do here then differently?
I use the Windows multi-byte to wide char function and convert it
Oh, okay.
to, which uses the Windows internal method, which it knows how to do all the byte expansion and
Okay.
all that kind of stuff. It has a effectively platform native like string to string.
Right. So
Although it's the C API.
Okay, got it. And then that would convert like
um,
your normal UTF-8 or whatever STD string into a W string
exactly.
that is properly.
Yes.
Okay. Yeah. Well, then that's
So
that's
this is kind
obviously
of like my
a
design
no-brainer.
like this. Yeah, I very much think that stood string should be used everywhere, and then you at the point where you have to do something else with it, you convert it at that point, and then you immediately convert it to a stood string again afterwards. So because also what I think you'll find interesting then is in Windows process helper you use was string convert. And that has been removed in 26.
Yep.
It was deprecated in 17 and removed in 26 because they basically said just use the platform one.
Yes. Okay. Yep.
Because I think, I could be wrong, I think the MSVC implementation of this in their standard library has a memory leak.
Nice.
Or at least it did at some point. So, actually, I do have a question for you, because I'm not a massive expert on sort of thread pinning and affinity and stuff like that, but I'm kind of curious, like, Magic 8 here, because this is a bit mask, right? So doesn't this mean that it will only then run on one core? Because 8's only got one in it.
Yeah, I don't know. But yes, it does seem like you're telling it to run on core 8. That's a bit weird. Maybe that was a debug thing. This was probably a debug thing where it's like, I want to check the usage of the render thread, and I'm just going to open up Task Manager and see if it's on 8 without having to right-click on the process and tell it to run on core 8 in Task Manager.
Yeah.
But that does
like the idea
seem...
that you want to set the name of it, and now you've lost all control of where it goes.
Yeah, I couldn't tell you why that's like that. That's a good point. Thread affinity mask. I wonder if it's like mask means
it's a bit mask, I think.
It's a bit mask. Yeah, but
wherever
8 is obviously
8
is obviously a single bit in the
yeah.
mask. Yeah.
Yeah.
That's
so like if it was like FF
that's
or
funny.
something, or yeah, I saw it and I was like,
yeah, what's even crazier?
For this.
I just realized this isn't the constructor either. It's the set name function.
No, yeah. It's not like there's a set thread affinity which defaults to like core 8 or something like that.
I want to quickly see when that was written and if there's any explanation in the commit message.
I think this is my last point, by the way. So
that was in the very first commit for that file in August 2022. It's basically the entire file, but yes, it was in fact added along with the entire rest of the class. So that is quite funny, and it's been running, and it's been running like that, and that was me. I take full responsibility for this. So that's hilarious. We finally
found some code you wrote.
Yeah, thanks for I wonder what this would even do if there's not even 8 cores or whatever. I guess it would just
well, yeah, I can't remember what the docs say. I think the call fails, but you don't check the return value, so you have no idea. I think it just silently fails.
I guess it's not a huge deal overall. Like, it's not going to impact the actual
run faster if you're not pinning it.
Application. Yeah, potentially. Yeah, because if other stuff is doing stuff on Core 8 for some reason. Yeah. But anyway, I'll just remove that line. Yeah, nice. You can do it as a pull request if you want. That'll be your first major contribution.
And I'll replace all your share pointers with unique pointers, and I'll add some exceptions.
This is good. I'll credit you for finding this. Cool.
But that's it. That's all I had. Like I said, I spent a couple of evenings kind of poring over this. It was absolutely fascinating. I had an absolutely great time.
Yep.
Like looking through it. I'm sure I could probably fill 3 or 4 episodes like this on stuff. but that was kind
Yeah.
of my first sort of initial pass of it.
Thank you guys for watching. I hope you enjoyed this code review. Huge thank you to Nathan as well for coming in and reviewing Hazel.
Thanks for having me. Yeah, it's been absolutely great. It's been a real blast kind of looking through some C++ code and talking shop to someone who actually knows what they're doing in the game engine space. I've been making my own game live, but I definitely kind of don't know what I'm doing. So it's been great to kind of get a bit of experience and hopefully, talk some more than C++, which I guess is kind of more my angle on things.
Yep, and I'm definitely hoping to do more of these in the future as well. I'll see you guys later.